So I'm going to be working on the next section for 4.5, the integration by substitution. So what I'm going to be working on right now is if we end up having, let's say, a definite integral, let's say I'm going from 0 to 1, of x parentheses x squared plus 1 to the third power dx. So when I'm looking at this specific type of problem, we still use the same process that we did before with the whole u substitution. But the thing is, there are two different methods about actually approaching the same type of problem. So I'm going to go over both of these with you. So for right here, I'm going to make my u value x squared plus 1. I'm going to make my du is going to be equal to 2x dx. So I need a 2, so I'm going to place a 2 here, and I'm going to place a 1/2 on the outside. Okay, just a quick check, right? The 2 replaces with the 2, the x replaces with the x, and the dx replaces with the dx. So that means that those values can now be replaced with a du. So I'm going to write 1/2 on the outside from 0 to 1 of u to the third du. Now I'll do my integration as I would do before. So I'd say u to the fourth over 4 with the 1/2 still on the outside. I'm going from 0 to 1. Now remember, if I'm going to 0 to 1, that was in terms of x. Since I switched over to u, I need to revert it back again. So I'm going to write this as parentheses x squared plus 1 over 8 from 0 to 1. And so what I'm going to write here is I'm going to write 1 squared plus 1. Oh, by the way, I forgot the 4. So to the fourth power over 8 minus, and this is going to be 0 to the second plus 1 to the fourth power over 8. So what I end up getting here is I get 2 to the fourth over 8 minus 1 over 8. And this will end up giving 16 over 8 minus 1 over 8, which will give us 15 over 8. And that's my answer. So if that makes sense to you, do this method instead of what I'm going to express next. Just kind of keeping the idea that if these values are in terms of the x and I switch it over to u, I need to switch it back to the x value in right here when it says u is equal to x squared plus 1, right? I need to convert that back. Now, I'm going to be working with the same type of problem. I'm going to show you another way of actually approaching this. But like I said, if the first way makes sense to you, you can listen to this, but you don't necessarily have to do this method. It's just another way about actually approaching the problem. So I'm going to go from 0 to 1, x parentheses x squared plus 1 to the third power dx. Still, we're going to use the same process. We're going to say u is equal to x squared plus 1. Therefore, du is going to be equal to 2x dx. Now, we still work out the same way, right? This is going to be 2. This is going to be 1/2. But what I'm going to do here is I'm going to change everything. Instead of it being in terms of x, we're going to change it in terms of u. So we know that the lower bound right here is 0. So I can say x is equal to 0. To convert that to be in terms of u, I can plug it into, in a sense, this u equation. So I'm going to say u is equal to parentheses 0 to the second plus 1. So I'm going to say u is equal to now 1. So the lower bound is now going to go from x is equal to 0 to u is equal to 1. And now the upper bound, right, when x is equal to 1, I say u is equal to 1 squared plus 1, and then u is equal to 2. So we're going to say that the upper bound is now going to be 2. So we're going to write this as 1/2 the integral from 1 to 2. Remember, these are in terms of u. I'm going to now say this is going to be u to the third du. So when I do the integration, u to the fourth over 4, the 1/2 is still out in front, but now we're going to say from 1 to 2, and we're not going to convert the u back in terms of x. We're just going to do our integration as we normally would, because this 1 and the 2, right, the lower and upper bounds, are in terms of u, so I don't need to convert it back in terms of x. So I'm going to write this as u to the fourth over 8 from 1 to 2. So 2 to the fourth over 8 minus 1 to the fourth over 8, which ends up giving us actually the same answer, 15 over 8. So does it matter which method you use? No. But that's pretty much the idea of how this works. If you understand how that goes, you should be good. I'm going to be doing another example for this. So just take a look at this from here. So the example is the integral from 1 to 5, x over square root of 2x minus 1 dx. See if you could actually try and do this problem right now. Stop the video, and then I'll work out the process on how to figure that out. If you just want the quick answer, the answer should be 16 over 3. Okay, so I'm going to work out this problem. I'm going to say u is going to be equal to 2x minus 1. Therefore, du is going to be equal to 2 dx. I'm going to say that since the lower bound is 1, I'm going to convert that. So I'm going to say u is equal to 2 parentheses times 1 minus 1. So therefore, the now new lower bound is going to be 1. And I'm going to actually say, oh, what this is supposed to be actually square root. So I'm going to change that up. So it's going to be square root. And then, oh, that's also going to change my du as well. So let's redo that. So u is equal to, oh, how did they do this? I don't necessarily agree with that. No, I'm actually just going to use 2x minus 1. Therefore, du is going to be equal to 2 dx. Okay, I see why they're doing certain things a different way. Anyway, so I'm also probably going to just be converting this again in terms of x. So u plus 1 over 2 is going to be equal to the x value. Now I'm going to do my lower bound. My lower bound is x is equal to 1. So I'm going to say u is equal to 2 times 1 minus 1. So therefore, the lower bound is going to be 1. So if x is equal to 5, I'm going to say u is equal to 2 times 5 minus 1. So u is going to be equal to 9. So that's going to be my upper bound. So now let's replace some things. So I'm going to go from the integral from 1 to 9. Replace x right here with this value. So I'm going to say u plus 1 over 2. And then multiplied. Now, keep in mind that this right here, right, is my u value, right? So that's going to be u. And since it's at square root, I can actually write that as u to the negative 1/2. And then du. I need to make sure I also put a 2 here and then a 1/2 on the outside. So 1/2 goes on the outside too. Because the 2 cancels with that 2, the dx cancels with that dx. Anyway, let's keep going with this. So there's another 2 out there, which is also another constant. So I'm going to write that as 1/4, the integral from 1 to 9. I'm going to write this as u to the 1/2, right? Because this is a exponent of 1. If I add it to the 1/2, that actually ends up giving me 1/2 if I distribute that. And then plus u to the negative 1/2 because I'm distributing it to that 1. Therefore, du. Okay, so u to the 3/2 over 3/2. Right, remember there's still 1/4 on the outside. Plus u to the 1/2 over 1/2. And then we're also saying as we're going from 1 to 9. Okay, so 1/4 bracket 2/3 u to the 3/2 plus 2 u to the 1/2, still going from 1 to 9. Multiply in the 1/4, so I end up getting 2 over, not 2. That would actually give me 2 over 12, which is actually just going to be 1/6 u to the 3/2 plus 1/2 u to the 1/2, still going from 1 to 9, and then evaluate this from here. So 1/6 parentheses 9 to the 3/2 plus 1/2 parentheses 9 to the 1/2 minus, right? And then so I need to keep that together. I'm going to write this as 1/6 1 to the 3/2 plus 1/2 parentheses 1 to the 1/2. Okay, let's evaluate this. This actually ends up giving me 3 to the 3rd power, which gives me 27. So it's 27 over 6 plus 3 over 2 equals, or excuse me, minus 1/6 plus 1/2. Okay, find a common denominator here. So in this case, I'm going to multiply the top and bottom by 3. That's going to end up giving us 36 over 6, and then minus, this is going to end up multiplying this by 3, multiplying this by 3, so I'm going to get 4 over 6 here. I'll just keep it with the same common denominator. So I end up getting 32 over 6, which ends up giving me 16 over 3. Which was that my answer? That was my answer. So here we go.